All right, so mine was the project that it was climate change and extreme weather. It does tie in a little bit to what Alicia just talked about, the ocean effects. Um, I started my first slide with a picture that I thought was interesting. I pulled this graphic from a scientific journal. And what this basically shows is three different portions of the Atlantic basin, especially the middle graphic there, where it says Dakar. That is the eastern shore of Africa, where it has the orange graphics and the squiggly lines there across the middle is what's called your main development region. It's your MDR. And a lot of, when talking about hurricanes and tropical weather, from the months of July, August, and even through the middle of September, which is the peak of hurricane season, that is where a lot of the core of your ocean heat comes from because of the latitude and longitude of where that sets up. As you see a lot of times in the Gulf of Mexico, Katrina was a great example. Everybody knows that one was kind of farther south. That came from a wave off of the western shore of Africa, which seemed to be not anything at the time, and then we know exactly what happened. It kind of wrote its own story. The bottom graphic is off of southern portions of, I believe, South America, is an additional hotspot, and this whole thing shows what is called your SST, your sea surface temperature anomaly. So how it compares to plus or minus where the temperature of the ocean should be. So getting back to the center graphic where it has some of the two orange boxes in the middle, if you correlate that to the right side with the scale is 2 to 3/10 of a degree Celsius warmer than average. And this was actually relatively recent at the time within the last years when this data was collected and published. So what is climate change and extreme weather? I've gone over two of the three definitions, but weather, for a review for anybody that doesn't remember, is an atmospheric condition that takes place on a day-to-day basis. Climate is the long-term meteorological averages over a 30-year trend. They use 30 years because it kind of bookends a period of time where they feel that it's not overly extended, but it's not too short to be considered a short-term trend. They want to find the average of long-term and what the future is projecting as far as data goes. And extreme weather is the third definition here, which is an unexpected, unusual, severe, or unseasonable weather events. A lot of times people think in the month of March, the transition month, a tornado in Kansas or the Southern Plains is an result of extreme weather. That's typical weather, typical climatology. About 6 years ago, we had a tornado outbreak in Massachusetts in February when it was 78 degrees. That is completely unseasonable. That would be a perfect example of extreme weather. The graphic that I chose with this one I thought was really interesting because it does cover everything from storm surge and flooding from tropical to severe weather and fires, which have raged California for really the last 10 years in portions of the western third of the states. That picture in the bottom right was actually post-Sandy. That is from the Jersey Shore, and after the water receded back to the west. I wasn't a big fan of it, the picture, but if you look on the far top left of that picture where it's almost like a white edge, that is what is the leading edge of the ocean water. And then you have the beach and what is left of the boardwalk in there. So it just shows the devastation that water from the shoreline can do. So hazards that are caused by climate change. They have an array of effects from flooding and drought, tropical, fire, temperature and sea surface levels are both rising, and severe weather. It also affects animal migration, economic value, and extreme hot or cold periods, as well as sea surface. The graphic in the top right corner here was a mixture of data from the IPCC and NOAA that was released here shortly, a few years ago. And I like this graphic because it shows the entire globe as far as the primary threats from heat waves to droughts, tropical typhoons, to severe weather. It basically shows how your latitude and longitude affects what your threat is, because we know the diversity of where people live across the globe is much higher in some areas versus other areas are not quite as dense. One thing that I did like that they did with this graphic is they tried to be very diverse and not categorize things similar to just storm surge, hurricanes, and tropical. They went with a wide variety. So they went with what affects people on different levels, not just one basic level. So I want to narrow this down. I went from climate change to extreme weather because climate change is such a broad category that you can really go in so many routes. But I went with a hurricane correlation and a tropical sense of this because there was a season in 2014 where Bermuda, and that's going to be the core of my presentation here that I'm into, had 2 storms in 6 days in October of 2014 that made direct landfalls on the island. Before 2014, dating back to almost 1600, that had never happened. And in the 6 years that have passed that season, it has not happened again. So it is a very historic time, and it's actually a presentation I wanted to do as my freshman year of college, and I never had the opportunity, and then this came along, so it kind of worked hand in hand. As far as hurricane correlation goes from climate change, you are warming sea surface temperatures, you are rising the air temperature as well. This allows additional moisture to be present in systems and storms, in updrafts that create the hurricanes and the tropical systems. You're also creating longer seasons. So what the typical June 1st to November 30th tropical season for the Atlantic Basin has now come over the last 5 years. There's been a system or two that has shown tropical entities by the end of May, where we start to get some of the early colder outbreaks in November, and then the winter begins to warm up. So you're cutting the season off in October. A few other issues as far as that are storm surge, which Alicia touched on with the coral reefs, and beach erosion for not just islands, but all coastal areas as well. This all correlates into having stronger systems, which are more threats to human life and as well as marine life and all aquatic features as well, including coral reefs, islands, mainlands, and everywhere across the globe. So I wanted to compare the hurricane season summary. So on the left side, which I went with a black and white image, I thought was interesting because it kind of is the past versus the current future, was this name of storms in the 2014 season, the Atlantic hurricane season. On the right is the upcoming summer season here of 2020. Now, what's interesting with these are the 2 systems that I'm looking at for this presentation are on the bottom left are Fay and Gonzalo. And both sets of names are actually the same. This is very unusual because you have storms like Irene, Rita, Katrina, names that are retired, that are historic, that are never used again. It's very rare that you have a set of names for a hurricane season, or a tropical season rather, that don't have any system strong enough to do enough damage and then cause enough loss of life that no names are retired. That either indicates a rather quiet tropical season or a lot of better fared luck where you have a lot of what's called a fish storm, which are storms that are out in the ocean that really don't affect any portion of land. In this case, it was the luck that really helped because there was a lot of storms. 2014 was a very active season, and thankfully it was a lot of loss of life was avoided in that situation, which is why we replicate the name 6 years later. I doubt that will happen again this year, but it's always hope for the best. So Bermuda's tropical history prior to 2014, I mentioned this a little bit here. Since 1609, when the Bermuda Weather Service began keeping records, 140 storms impacted the island in one way or another. Now, when I say impacted, that's not a direct hit. That's something from maybe just a little bit of wind, a little bit of rain, maybe some storm surge and some wave action along the shore, something in some form or fashion. 21 of those seasons, though, had multiple storms impact the island. So there may have been 10 storms in a season, that two or more storms in some way impacted the island, but only one of those storms in each season took a direct hit to either the mainland or the surrounding marina locations. And again, I talked about 2014 had two direct landfalls. There was a total of, I believe, 4 storms in that season, but the first storm was in August, second was September, and then storms 3 and 4 took place within 6 days in October. So Bermuda is located, as far as longitude and latitude, 32.3 degrees north and 64.7 degrees west. So you would normally think that an island out in one of the largest bodies of water across the globe would be a prime target. But that actually hasn't been the case because of it being such a smaller island. And it is a little bit farther north compared to the Bahamas or the Caribbean, that you do play with the water temperature a lot. So your ocean water cools as it goes farther north, which sometimes enhance the potential for missed storms, which thankfully for them, they got away with for the most part until 2014. So I want to move on to the first storm. This is Hurricane Fay. Hurricane Fay was a tropical storm that well overachieved as it came across the main development region across the central Atlantic off the western coast of Africa. In the bottom left here, you can see it's a tropical storm as it's heading towards the island of Bermuda, and this is timestamped at 8 a.m. Saturday, October 11, 2014 in the bottom left-hand corner. Bermuda is that small island right above the A and Y in Fay. Behind it, the 2 yellow X's are tropical waves that are following its path. On the top graphic there, you can see before it is arriving in Bermuda, the weather service there, the blue little dots there along the track on the northwest flank have already issued tropical storm warnings. Those were posted 24 hours in advance of the system, and tropical storm watches were posted 48 hours in advance of the system. This was a storm that was only into the low to mid 40 mile per hour range, which is a low end tropical storm once you reach 36 miles per hour. But by the time it reaches Bermuda, it is near hurricane status at almost 74 miles per hour. It's a strong end tropical storm. And it actually is what was considered a primer storm, because as this continued to churn up warmer water during its path, in the bottom right graphic where the red X is with the cone-shaped region is what became Gonzalo, the next hurricane that was even more forceful. Now that was thought to be taking a northwest track towards towards the Bahamas, maybe towards the Gulf, the peninsula of Florida. What was found was that between both storms, and the National Hurricane Center did publicly admit this, that beyond 48 hours, both of the models that predicted these systems did not do well. Neither one of them predicted that Bermuda would take a direct hit, let alone really take any impacted hit at all. And especially with the second storm, there was even more of a struggle because Fay was already upon the island in itself. So what did it look like as far as radar and satellite? So Hurricane Fay on the left, this is the actual radar image out of the Weather Service in Bermuda. There is a little bit of an eye that had developed as the storm began to strengthen and push as a Category 1, just over Category 1 status here to the northeast side of the island, as it really swiped the west side. So the issue with that was that there was additional rainfall because of the track. Had the track been farther to the east, Bermuda would have been a little bit better off because of the parallel winds. The perpendicular winds. If the winds would have been parallel to the island, then it would have been a situation where they would have avoided as much flooding as they had. But unfortunately, the way the track went, it steered farther to the northwest, which was almost prime for flooding and additional damage to the island. Bermuda itself, obviously, is not a large-scale island, so they're very susceptible to having larger storms virtually wipe them out compared to a mainland or something along the eastern shore of the United States. The center image there is what you can see to be an eye on the visible satellite. It does have what is called the lung structure. So you can kind of see where it fans out, sort of like a fan blade. That's the inflow within the rising and lowering of the air across the eye wall in itself and the updrafts. And the first sign of issues to come before anybody really knew how bad it would be was wave action and beach erosion. Before any rain and before the wind really began to whip up, you had ocean effects before the storm itself got to them. As far as impacts from Hurricane Fay, it was an early morning storm. It made landfall at 5:10 in the morning on October 12, 2014. It was the first landfalling hurricane since 1987 when Emily hit, and it was the strongest that had impacted the island in 11 years since Hurricane Fabian hit at a Category 3. Biggest damaging wind threat, they had reports of nearly 80-mile-per-hour winds at the airport. Commissioner's Point, which is a higher point, almost a cliff-like structure on the west side of the storm, had winds gusting to almost 130 miles per hour. There were several tree, utility, and power outages reported across the entire island. What was thought to only be a few weeks, being Category 1 storm, they weren't struggling overly bad as far as getting ahead of damage control, but 27,000 people were without power. The storm was relatively expensive in the sense that it cost $3.8 million, and they thought that was going to be bad enough when looking at the fact that they also had 14 inches of rain in the month of August alone, an additional storm in September, and now with this storm beginning of October, within the first week and a half, flooding exacerbated that issue and just really was the icing on the cake. Marina damage was also very heavily reported as well. Boats were destroyed, they were thrown across roads, and a lot of the major roadways were completely wiped out clean. Now moving on to Hurricane Gonzalo, a little bit of a similar setup here. Again, to the left side, you can see the difference in the structure compared to Hurricane Fay. It has much more larger in size, it's more spatial. You can also see a much more well-defined eye, similar to a typical strong hurricane. If you look to the northeast, there's the word Bermuda and the island you can make out slightly underneath of the cloud cover out ahead. It was probably the day before, I believe this was, because the Turks and Caicos Islands to the southwest that you can make out with the clouds beginning to clear in that region. So it was more than likely a beautiful day beforehand until everything moved in all at once. The center graphic here was from the National Hurricane Center, and this was already at a 65-mile-per-hour tropical storm as it was exiting the eastern Bahamas, Puerto Rico, and the DR. And again, if you remember that graphic before where it looked like it was headed towards Florida, like I said, the models they admitted the past 48 hours did a horrendous job. And again, similar to Fay, took a northeast curvature and really was going to sideswipe this time the southeast shore of Bermuda, which helps in the sense of having parallel winds, but it really enhances the flood threat if it hits during the right tide. On the right, I found this graphic here from the National Hurricane Center as well out of Biloxi, Mississippi. The purple line here along the east side of Bermuda is the exact track of where the eye was. Once you reach that purple corridor, you're talking a Category 4. On the northwest side, the first storm there that has the red along the northwest side of the island, that's a Category 3 from a previous storm. They had not had time at the time of Gonzalo's impacts to even map out Fay because of the warnings and the data that needed to be posted for the public safety. So it's interesting because normally you have data coming out immediately from a system, whether it's a tropical system, a severe or weather system, or winter system, that you can correlate to each storm. Where in this situation, you had back-to-back storms within 6 days, and with less timing than expected, you really didn't have time to separate the data until after both storms were done. So it's always going to be a little bit of a mystery. How much did Fay cause compared to Gonzalo, and how much additional damage did Gonzalo cause that was already done by Fay? Because the correlation is so tight. One thing I do want to note with Hurricane Gonzalo is that it did undergo rapid intensification. As it was exiting with hurricane warnings out of the eastern Bahamas here and Puerto Rico, It was already, like I said, a strong tropical storm, 65-mile-per-hour winds pushing a Cat 1, but would eventually become a major hurricane here as it comes up to Bermuda within a matter of 4 days or so. The models, again, did not do well. Now, there was one model that was forecasted at 96 hours out, and it was very accurate. Being it was only one model, they discarded the data and said that just isn't going to happen because it didn't have a reliable past. I think now looking back at it, had they had any clue that would have been the right model to go with, they could have warned people a little bit better. They probably rethought that idea. Radar and alerts for Gonzalo, again, a stronger storm. As it moved into Bermuda, it's got a much more wrapped eye. The eye wall is certainly stronger. It's about 30 miles wide here. It did make landfall with additional flooding and winds as a Category 2 to a Category 3. It was right on the edge within about 3 miles per hour. The wave heights around the ocean, around the island, were 44 feet tall. The good thing is about the storm is that the storm surge was only 2.6 feet because the storm thankfully hit at low tide. Had it hit at high tide, they expected the storm surge to be anywhere from 5 to maybe 18 feet, which would have been a completely devastating blow to what was already a weakened coastal area. And they really only had 2 to 3 inches of rain. So a storm that was this wide, usually when you have a system this strong on the top right quadrant, if you cut it into 4, sort of like a graph, usually the top right quadrant is where you have the most and heavy precipitation. You hear about tornadoes and severe weather from that. That's where that occurs as well. They missed that part of the storm. So that was a big benefit to the island themselves. The picture on the right there was taken after by an aircraft that was flying over to do some damage surveys. All of the surrounding light blue water is actually sediment that came from the bottom of the ocean. There was so much upwelling from the storm because of the rapid intensification that it brought the soil, the sand, anything from the bottom of the ocean and brought it farther north towards the surface around the island itself. So what kind of impacts did Gonzalo have? Complete opposite as a 9:30 p.m. landfall compared to a 5:10 a.m. for Fay. Again, I mentioned it was at low tide. The good thing with this one was the winds were parallel to the island, so most of the modern day structures at that time survived, but a lot of walls and groups from older structures really collapsed because they didn't have the strength to withstand another hurricane. They weren't built as strong, and the support just wasn't there. Additional tree damage, utility damage, and structural damage was widespread across the entire island. There was reports of about a 30-minute calm period as the eye passed on the southeast portion of the island. So usually when that happens, I'm thinking the eye was roughly to 20 to 30 miles wide. And marine damage was catastrophic as well, as additional boats were tossed and thrown actually into buildings as projectiles from this storm. The highest winds that were recorded was actually from what's called St. David's Lighthouse, which is on the northeast side of the island, pushing 144 miles per hour as a storm closed in there on the island itself. No reports of deaths immediately were after. However, there was an 87-year-old man that was killed by the storm. Unfortunately, he was in a boat in a marina. Not sure exactly why he was out there at that time. And there was also 2 additional people that were considered missing. They were never found, so they just added those 2 to the death toll as well. There was 2 additional people that were killed and 4 additional injured as the storm raced through the northern Atlantic and actually got all the way over to Great Britain as a post-tropical cyclone. So it was strong enough where even the really cold ocean water in the northern Atlantic and over towards Europe really didn't slow it down enough to really be more, I guess, of a windstorm and less of a rain event there as well. The overall monetary value to this storm was $200 to $400 million, and that does not include what Fay had already damaged the island. So combining both of them, they estimate a closer $300 to $350 million at least that was done. And those estimates, I'm sure, have gone up because they didn't complete damage surveys for about 6 months afterwards, being that the time of the year was heading towards winter as well. What causes both of these storms and Bermuda impacts? The Bermuda High is the very first answer. Bermuda High is a large high pressure centered over the central Atlantic that varies and wobbles from east to west depending on how the jet stream flows. Strengthens, it pushes storms around the edge. When it's weaker, it allows the storms to infiltrate through the high pressure and basically knock it out of place. So depending on where that high pressure sets up, depends on if it's more of a coastal storm for the eastern seaboard, or is it a storm between there and Bermuda, or is it a storm that it just goes out to sea, doesn't affect anybody. Tropical wave tracks, those waves that come off of the western shore of Africa there. Often if they're farther to the north, a lot of times the way the high sets up, it'll hook out and east of the island. If they're farther south during the MDR region, they are farther south and west and usually come up between the eastern seaboard and the island of Bermuda. So then it's a question of which direction does it go? Is it closer to the island? Is it closer towards the mainland? And the time of the season, of course, because the water temperature isn't the same in March and April as it is towards the end of the season in October and November. So the time of the season and the strength of the storms certainly play into that as well. I posted 5 maps on one side, and I thought it was a little bit excessive, but I didn't want the data itself to be the one thing to look at. The thing I was trying to take away from this is from the top left to the right is the seasons of 2015, 16, 17, 18, and 19. Each one of these systems is color-coded by the National Hurricane Center for every storm of every season, along with their strengths and their tracks. And again, I mentioned at the beginning, but since 2014, there's been only 4 storms to impact the island at all, and only one of them since 2016. So to emphasize the point of only having one little island in the middle of a massive body of water, you think that's got to be a direct landfall, but it's really not been. They've been very fortunate since, I think, which emphasizes the 2014 season, how historic it really was and how unique it really has been, even including previous history, all the way back to 1906. And as far as the future tropical outlooks, what do we expect from today through the rest of the tropical lifespan? I think the left side here, it sort of shows the tail. The black line here is your mean, your average sea surface temperature. This is data all the way through April of last year in 5-year increments. It starts back in 1900. So the beginning of next year, they'll add the 5-year increment for 2020. That's why that's not on there yet. And then the red lines that zigzag north and south of the average there is basically the individual seasons as well. But similar back to 1970 or so, again, the sea surface temperatures have been rising steadily. They have, so far the last few years, look like they've tailed off and just slowly been rising, not quite as exponentially, but it is still much higher than where it should be. Right now this year, there's 80-degree warming all across the Gulf of Mexico. That usually doesn't happen until the middle of July. And we're not even to May yet. So we're 3 months ahead of schedule. There on the right is the typical season. Again, June 1st to November 30th is the tropical season. What I like was when they made this graph, they overlapped it over the last 100 years with a number of storms for hurricanes and tropical storms, then just did hurricanes separate, as September 10th is the peak of hurricane season. And there's a second peak usually, if you look there, right around before October 20th, which is interesting because it correlates exactly when these two systems hit Bermuda during that season.